Hello guys, Art-Teeves here. In this video, I'll take you through the entire process of 3D modeling, unwrapping, baking, and texturing a low-poly plant using 3ds Max 2024 and Substance Painter. The final project consists of approximately 300 polygons and features a 1K resolution UV map. While it may be slightly excessive for mobile games, it will perform perfectly in PC indie games. This plant is composed of stems with 4 sides and bulbous structures with 16 sides. To optimize performance, we've opted to not join the stems together. This leaves open edges where they meet, allowing them to simply intersect, unlike our previous plant design. To save time and effort, I incorporated 5 high-poly spheres that I have modeled in a previous project. A detailed tutorial on the modeling process for these spheres can be found in a separate video. To achieve a different aesthetic and simplify the geometry, I opted not to include the spiraling stems used in my previous project. These stems, while visually interesting, would have required a significant number of support edges, potentially sending our polycount through the roof. I create stems by generating splines with smoothed edges. I then use a 4-sided cylinder, essentially a square, as the loft object. Since plants are rarely symmetrical, I intentionally create a one-sided asymmetry in the stem. When modeling more intricate props, it's beneficial to pre-plan the best rendered sides. The greater the number of well-rendered sides, the more visually appealing the final result will be. I switch between side views and meticulously edit the curves of all stems. It is crucial to avoid excessive curvature, as this would necessitate a significant increase in support edges, adversely impacting the poly count. Finally, I create a circle, adjust the number of its sides to 4, and utilize it as the loft object for my splines. I then proceed to edit the curvature of resulting lofts, ensuring they exhibit non-linear characteristics. This process is relatively straightforward and doesn't involve any unique techniques. To simplify the plant further, reduce the number of support edges that contribute to the stem's curvature. Additionally, decrease the number of stem sides. For more detailed plant stems, I find an ideal number of sides is typically below 6. The next part of the process focuses solely on refining the curvature of the lofts. To avoid redundancy, I've skipped this portion in the video. I ensure that all intersecting splines intersect cleanly and that their open edges are not visible from any perspective. It is crucial to avoid situations where intersecting splines share the same plane, as this can lead to visual artifacts known as Z-fiding. I duplicate my stems, delete their caps on both sides and trim down their poly count by using dot loop and ring select tools. I minimize the number of support edges on the low poly stems wherever possible. Next, I use the Align tool to place my low poly stems on top of high poly stems I have made before. I carefully observe the stems, ensuring proper intersection and the absence of any visible open edges. Next, I create several boxes, convert them into editable polygons, and apply NURBS to transform them into easily unwrappable spheres. I then utilize the Align tool to precisely position the low poly spheres on top of the high poly spheres and ensure proper rotation. First, I set the amount of iterations of my NURBS objects to 2. It gave me some excessive polygons, so I have trimmed it to 1. It may look edgy later on, but this is a low poly plant after all, and we won't be watching it up close. To enhance the realism of the plant, consider placing larger, heavier spheres on thicker branches. This simulates how larger fruits or flowers might be distributed in nature. Additionally, position smaller spheres towards the top of the plant, creating a more organic distribution of weight. To avoid redundancy, I'll skip the part of the video where I adjust the placement and size of certain spheres. This involves minor adjustments to enhance the overall visual appeal. I carefully align the high poly and low poly stems to ensure accurate baking. Feel free to add any number of support edges to your high poly stems, or even apply Turbo Smooth with multiple iterations. This won't impact the final topology, as long as the high poly stem maintains the same overall trajectory as its low poly counterpart. Holding the Shift key while adding an edge loop in 3ds Max encourages the software to consider the existing polygon flow of your model, resulting in a more organic and visually appealing edge loop placement. I trim down the polycount of my spheres, give all my stems and spheres a single smoothing group, clear any existing UV maps, and proceed to UV unwrapping. Pay close attention to the naming convention for your stems and spheres. Ensure that corresponding high poly and low poly objects share the same base name, but with distinct suffixes to easily differentiate them. While unwrapping the boxes into cross shapes is a viable option, I prefer to split each box into 6 separate sides. This approach allows for more efficient utilization of available UV map space, potentially resulting in higher resolution textures and improved overall quality. The positioning of vertical stem seams has minimal impact on the final result. Instead of meticulously straightening them, we will relax and normalize them to prevent potential seam anomalies during subsequent steps. If you know the anticipated viewing angle of your model within the scene, strategically placing seams on opposite sides of each stem can minimize the visibility of seams in the final render. This approach can enhance the visual appeal of the model by reducing the prominence of any potential artifacts. I simply align my stem UVs manually, add spheres to the same map, and normalize all UVs. Then I play around with some sphere UVs to fill up my map completely. It is generally more efficient to group multiple plants or mushrooms together within a single UV map, rather than creating separate UV maps for each individual element. This approach optimizes UV space utilization, leading to improved texture resolution and overall efficiency. The stems are correctly normalized and their UV chuck sizes are proportionally balanced. Avoid resizing individual UVs within a sphere. Instead, resize all the UVs of a single sphere uniformly to maintain consistent scale and avoid potential distortion issues. Ensure that the centers of corresponding high poly and low poly spheres align precisely. Position the center of each stem at the midpoint of the bottom section of the central stem. Finally, group all elements and position the entire assembly at the 0, 0, 0 origin of the scene coordinate system. After I'm done in 3ds Max, I send my model to Substance Painter. There, I set the highest possible amount of raise on all tabs, disable the ID section, set object interaction to same named meshes only, and bake my UVs to a 1K Reso UV map. To ensure seamless integration with your 3ds Max workflow, maintain consistent naming conventions in Substance Painter. Use the exact same suffixes for your high poly and low poly objects in Substance Painter as you did in 3ds Max. If you want to optimize your plant even further, you can avoid using the normals map at all and simply paint all details. Obviously, resulting JPEG texture will take much less space than a typical PNG. I start texturing most organic objects by giving them a preset Creature Skin Green Smooth smart material. I play with its colors, duplicate it, make its top version brighter, add a black mask to it, and then fill it with a linear gradient map. Next I create a height data layer, and only use its height channel, which is raised compared to other layers, to give stems some nice texture by applying a preset grunge map 005 to them. Finally I create a highlight layer, mask it, add a mask editor to it, and edit its curvature settings to give my stems some nice brighter highlight. In this specific case, normal maps might not be crucial for achieving the desired visual outcome. You can potentially apply a grunge map directly to a color fill layer, bypassing the need for normal baking altogether. While this approach can simplify the texturing process, it's important to acknowledge that it will likely require more manual effort and artistic skill in Substance Painter to achieve the same level of detail and realism compared to using baked normal maps. I used the same technique and same default smart material to color those spheric bulbs. I create two versions of this material, mask the darker one, reduce its roughness, apply a paint layer to it, and use it to paint those spherical holes. Also, I create a height data layer, increase its base height, mask it, and apply a fractal sum base colored fill layer to it. I changed the blending options of the black layer I create to multiply for it to override the height data we've added before. You can also set it to replace if you want. I'll skip most of the painting process here, there is absolutely nothing special about it. You may want to use the hardest brush possible here. After I'm done with colors, I add a baked lighting stylized and adjust its colors and angles. You may want to cover all visible UV seams before you do it. To do it, you shall create a paint layer, set all of its blending options to pass through, and use the clone stamp tool to hide all anomalies. And this is it. Thanks for watching, guys. If my videos are of use to you, please be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.